Okay, welcome back to your next lesson in magnetism. We're moving on to magnetic fields. So, learning route map for today. What is a magnetic field? How can I plot magnetic field lines of a magnet? And how can I draw the magnetic field patterns of interacting magnets? Okay. So, before we jump into magnetic fields, let's recall what is a field in physics. This is something that you should be familiar with because we've talked about it twice, right? Once in mass weight density and then recently in electricity. So we have gravitational field and electric field. What are these things? Do you remember? So a field in general, if you remember, is a region of space where an object will experience a force. A region of space where an object will experience a force. This is generally what a field is in physics, right? So we have specific examples that we've covered. For example, gravitational field, where the region of space around the Earth or around any mass, if you put an object here, it will experience a force in this direction given by the arrow. Okay, so we call these things field lines. They show us where is the field, in this case the gravitational field, and they tell us where the object will experience a force. They also tells us, the closeness of the field lines also tell us how strong the field is, right? So closer to the Earth, you see that the lines are closer, so the field will be stronger. The further away you are from Earth, the further apart the field lines, the weaker the field, right? So the weaker the force that the object will experience, right? So that's gravitational field. We also know of electric field, which we just talked about recently, so it should be fresher in your mind. You should be able to know how to draw this field pattern around a positive charge, and what do the field lines represent in this case. It is also a region of space where an object will experience a force, but specifically what type of object? For electric field is a electrically charged object. And in fact, even more specifically, it's a positive test charge, right? A small positive test charge. So if you place a small positive test charge here, where would it experience a force, right? The force will be experienced in this direction, right? Following the arrow. So if I place a small positive charge here, it will experience a force in this direction. Obviously because positive and positive repels, right? And so we have this region of space around a charge where a positive test charge will experience a force in a certain direction. Okay, that's what the field lines represent. But of course, any charge will experience a force, and it's given by the field. Okay, so same thing, the closeness represents how strong it is. So I think this should kind of set the backdrop such that magnetic field is going to be pretty easy because you've already learned enough about fields, especially from electricity. Okay, so what's a magnetic field? A magnetic field is a region surrounding a magnet in which a magnetic object experiences a magnetic force. Okay, it's basically a field, but specifically for magnetic objects to experience a magnetic force. So we had this experiment earlier where we hung a magnet, and now you know that the region around the magnet has a magnetic field such that an object brought into the magnetic field will experience a magnetic force, which is why this thing gets attracted here, right? So we don't really know what the magnetic field looks like yet, but we know that there's a region of space around here, and that's why this thing experiences a force. What this experiment also reminds us is that firstly, magnetic force can act at a distance. Okay, magnetic force can act at a distance because the field is the region of space around the magnet. Next, direct contact is not required for magnetic attraction or repulsion to occur, and the field can be visualized with magnetic field lines. Okay, the field can be visualized with magnetic field lines, just like the other two fields that we've already learned. A group of magnetic field lines form a magnetic field pattern. Okay, this is just telling you the terms. Okay, so the magnetic field pattern is the group of field lines. They form a magnetic field pattern. So how do we know what do these magnetic field lines look like for a magnet? Okay, how do we know what the magnetic field pattern looks like? There are two ways to show the magnetic field pattern of a magnet. One is by sprinkling iron fillings around a magnet, and then the other is by plotting the magnetic field pattern with a compass. Okay, for this video, we're going to cover what a magnetic field will look like through the sprinkling of iron fillings around a magnet. Then later in the next video, we'll talk about plotting the magnetic field pattern with a compass. Okay, so sprinkling iron filings around a magnet, iron filings around a magnet. What are iron filings? Basically, it's just you take iron and then you file it into little like filings. It's like iron powder basically, and then you're going to sprinkle around the magnet, and the iron powder is going to fall naturally because of the influence of the magnet. So I'm just going to let you watch a couple of videos to let you see this. All right. So you can see that the magnets, the iron filings in the liquid have naturally formed around the magnet. Okay, and something that you can observe is you see that a lot of them are bunched up at the ends of the magnet, which suggests that the magnetic strength here is really, really strong. The magnetic field strength here is really, really strong. And that's something we've learned about properties of magnets, right? That the magnetic field strength, or the magnetic strength, is strongest at its poles. And then we see, hey, they seem to be forming these lines. You have to use a bit of your imagination, but I think it's relatively clear, right? They seem to be forming these lines. So they come out and then they curl around from pole to pole. Right, so we start to get a feeling of, hey, this is kind of how it looks like, right? Let's watch another video just to see this again. Okay, so in this one, the magnet is underneath the paper and they're sprinkling the iron fillings directly on top of the magnet. And once again, you can kind of see the shape forming. And again, a lot of them are bunched up at the tips. Like a lot of lines are coming out from the tip. So if we were to use arrows to represent it, it would look something like this. So what we have two magnets, and we put the North Pole and the North Pole close to each other. What would the pattern look like? Very interestingly, we see that we have nothing in the middle because everything here is repelling each other, right? North and north. And we see the few lines, whoa, they're like going out and they don't meet in the middle, right? Okay, they're not supposed to meet in the middle, so this was a mistake by the video, so I erased it away. And what about during attraction? So North Pole here, South Pole here. If you do the same thing, what would you expect? Oh, you see so much field lines going across, and in general there's still that curvy pattern around. The field lines are meeting in between the two magnets. So this would look like this, right? Okay, yeah, so now the sprinkling of iron filings kind of give us I don't know, a guess of what the field lines would look like. Help us to imagine what the field lines would look like. But can we know for sure? How can we plot the field lines of a magnet, right? Experimentally, other than by filings. We're gonna learn how to do that by plotting with a compass, and you'll do that in the next video. All right.